to help on some of these addition, multiplication, division problems with fractions, just to give you an example of each type. So I'm going to work through number 5 to start off as the addition version, and it is 1 1/4 plus a negative 3 5/6. So anytime you're adding or subtracting fractions, you got to get a like denominator. But before I even start there, I would notice that the signs of the two are different. So I know that I'm going to be finding the difference of the two numbers. And 6 and 4 have a common factor of 12. So I would rewrite these as 1 1/4. I'm sorry, not 1 1/4, but 1 over something in 12, and it wouldn't be a 1. It would be times 3, because 4 times 3 gives us 12. So we have to do 1 times 3. I'm going to rewrite the first fraction like that. We have to multiply the 6 by 2, so that 5 is going to become a 10. So negative 3 and 10 twelfths. Once we have our fractions the same, denominator-wise, since the signs are different, we're going to subtract them. You can take this a different route and change them to improper, but I prefer to just subtract them since my larger mixed number has a larger numerator. So this will actually work out pretty well in my favor when I try to subtract numerator to numerator and whole number to whole number. 3 minus 1 is 2, and 10 minus 3 gives me 7. So I end up with this, but if I look back, I notice that the negative has greater absolute value. So that's going to be my final answer. Negative, because it has greater absolute value, 2 and 7 twelfths. All right, let's move on to number 6. Now, number 6 has you do a subtraction problem. Negative 7 3/10 minus negative 4 4/5. I'll get that written down there. That's negative. Anytime we have subtraction, I've advised you guys to change that to addition of its opposite. So the first thing that I would do with this problem is realize that you're actually adding two different signed numbers together. Add its opposite, 4 and 4/5. There we go. And this kind of goes back to the same problem as number 5. After you do that step, is you just need to subtract them. You only need to change the denominator of the second fraction because you can get a like denominator of 10 when you do that. And that's pretty simple to do. So we're going to rewrite the second fraction as a 10 in the denominator, because that's the common denominator that they share. And that's going to become 8/10 instead of 4/5. Just double the 5, double the 4. Same fraction, same value, just matches the first fraction better now. And we're going to do a little subtraction like we did in the first problem with the larger number on top. And we're subtracting 4 and 8/10 from it. If we look at these two, the negatives are going to win the battle, but we have a problem here. We can't just do 7 minus 4 and 3 minus 8, because 3, you can't take 8 away from it. So you're going to have to borrow from the 7 to give you 6. And this doesn't always happen, but since our denominator is 10, we're going to add 10 to our numerator. If our denominator was 7, we would add 7 to it, but luckily in our case, the denominator is 10, so it looks like your typical subtraction borrowing. 13 take away 8 right here is going to give us 5. And 6 minus 4 is 2. So that gives us essentially 2 1/2, right? Because 5/10 is the same as 2 1/2. And the negatives win. So negative 2 1/2 is what we're looking for when we match. Number 15. Right, number 15, 3 5/9. This is going to be an example of a multiplication problem. We're multiplying by negative 9 32. Negative 9 over 32. When I'm multiplying numbers, you have to change them to improper fractions. It's an option when you do the addition, subtraction, like over here. But when you're doing multiplication, it's imperative. You have to do it. 3 times 9 gives me 27. 27 plus 5 gives me 32 over 9.